Bismillahirrahmanirrahim. Still on domain and range, now we have another examples that involve the rational function. So this is the equation fx equals to 1 minus 3x over 2x plus 1. Okay. So in order to identify the domain, we are looking for the values for the function becomes undefined. So it is 2x plus 1 cannot be equals to 0. So the x cannot be equals to negative 1 over 2. Okay, so the domain should be all x elements for real number except for negative 1 over 2. Or this is in terms of interval notation. Okay, why? For the range, it is stated before that the range of the function of f is equivalent to the domain of its inverse. So maybe for this equation, we can find the inverse first. So just like this, y equals to everything that we have, 1 minus 3x over 2x plus 1. Okay, so we need to move this times with y. And expand for this to xy and y. So we want to make x as the subject. So move this 3x. And now factor for x. It is 2y plus 3. So x should be 1 minus y over 2y plus 3. Okay. So this is the value for x now. Okay. So that we can find the inverse of f. Okay, it is equals to 1 minus x over 2x plus 3. So that the the range can be 2x plus 3 cannot be equals to 0. So that x can be equals to negative 3 over 2. Okay, so this is the things that we are looking for in order to identify the range. Okay, so as you can see previously, the value of the range is all the number except of 3 over 2. Negative 3 over 2. Yes. Okay, so you can also write the notation in terms of interval notation. That's for number 4. So next on number 5. Okay, so this one should be number 5. Okay, so now this is the function in terms of radical root of function. So as you know that for the root of function, the x value, okay, the values of domain here cannot be equals to negative values, right? Okay, so for that we can take the values of x plus 1, okay, with this root of always should be equals greater and equals to 0. It can't be negative numbers. So that your x plus 1 greater and equals to 0. So x greater and equals to negative 1. So therefore, the domain can take for any values of real numbers that x values is greater and equals to negative 1. Or in interval notation, this is the answer. For the domains, it is negative 1 included until infinity. Okay, why for the range of fx, it is elements of real number and fx is greater than 0. So if you noted the basic graph of root of x, okay, the basic graph of that should be in this kinds of shape, right? Okay, so that the values of fx here always equals to always the values of that should be greater and equals to 0, right? Okay, so that's the range, and we can also write that one in terms of interval notation. It is 0 included until infinity. Why for example 5? Okay, so this one given in terms of rational with the radical function root of x plus 1. Okay, when it involved with the rational function, always noted that the values cannot be equals to. Okay, so that's why here we just take the values of x plus 1 greater than 0. Okay, so the x is greater than negative 1. So this is the domain value, x elements of real number where x is greater than negative 1. Okay, why for the values of the range, it should be fx greater than 0 because it is still in terms of radical function, root of function, so all the range should be positive. Okay, so next we will continue with another examples that involve with quadratic and also cubic. Okay, so now this one also you need to change just the numbering. Okay, it should be for number 7, and also the next is 8 for the cubic function. Okay, so the next function here we have in terms of x squared plus 1. So if you noted, recall back the basic functions of quadratic, this is for x squared. Okay, this is for the functions of x squared. Since we have here x squared plus 1, so it should be shift 1 unit upwards. So this is the graph for x squared plus 1. And the domain should be all real numbers, okay, because it covers everything in the x-axis from negative infinity until infinity. And the range should be the values from here, okay, from 1 until positive infinity, right? Okay, so f(x) should be greater and equals to 1, or in terms of interval notation, it is 1 included until infinity. Okay, and the last example here is involved with the cubic function. So it is x cubed plus 1. So basic function for cubic, I think you can sketch. Okay, this is the same slide. Okay, the basic function for cubic x cubed. Okay, so this one, it is x cubed plus 1. Okay, so you will have the function that cut at the y-axis of 1, okay, when x is equals to 0. So for this kind of function, you can always note that the the domain should be all the values here for x from positive to negative infinity. It will cover everything. So that's why x is the elements of real number. And for the range also, as you can see, the graph should goes until positive and goes downward until negative infinity. So the range also will be fx elements of real numbers. Okay, with that, at least we cover for the basic kinds of function, okay, finding the domains and also for the range. So the next example, we will go precisely with the exact numbers, exact function, more specific, in order to identify the domain and also range.